Hey, so recently I started working on a THX deep note recreation in C, in the C language, programming language, which is what it was originally made in by Dr. James Andy Moore. And he made it in C with two primary parts, the main C and the synthesizer C. So this is the original file right now. I didn't play the wobble part because I'm not working on that right now. I'm gonna do that later. And this is my recreation. So obviously it's less chorusy and it's less richer, but I'm going to the richer. I'm gonna add more richer parts. I'm gonna add more chorus. I'm gonna add more LFO, and it's going to be I'm gonna add more voices. So right now this is not at the 30 voices, which the original deep note was made of. And this one's 21 voices, I'm pretty sure, or 22. So in the code, I have this function called get synth test value. So what this code does is it takes the stuff from the synthesizer file. I'll get into that, and then it writes it to a wave file called wobble.wave, which is what essentially the original program did. It synthesized it. It wrote it to a it wrote it to a file, and then it played. I'm pretty sure Dr. James Andy Moore could also synthesize it in real time. So I have all of these voices, and what these parameters do are, first of all, this one's a starting point. So if you want your LFO to start earlier or later, you can add this. You can divide it by 44100, which is what my sample rate is for this is going to be 44100, and you'll get the number of seconds which you will delay it by. We have the frequency over here. We have the LFO, kind of like how much you want it to, like, LFO, how much pitch you want it to vary, and then we have how much time it's going to take for it to vary. This is a divider. So we have 37.5. There's going to be another 37.5. There's going to be 75, 75. There's going to be 3 notes which has 2 voices each, and there's going to be 8 notes with 3 voices each, and they're going to vary in pitch a lot so that it gets more richer. And then obviously there's also going to be 2 channels. Right now I wrote mine in mono, and it's going to be 2 channels. So getting into the oscillator, I have all these functions. Right now I'm working on a struct which has all of the characteristics it needs to calculate exactly what sample it's going to be. It's going to do basically essentially what the new function is going to do, essentially what get synth test value does, except with all of these parameters. And for these parts, this is actually part, like, people get this wrong in a lot of remakes. There are these steps on the rise to the big deep note. So this part, it's not linear. People think it's linear. It's not linear. Over here we have all these steps over here, 1, 2, 3, and then 4 before it goes to its big note. And I'm gonna add that with, I'm gonna find exactly what frequency it's going to be in before each step. I'm gonna find exactly which frequency each step is going to be in. After that, it's going to be, well, then I just have to work on the wobble. So let's go into the synthesizer. Over here we have the actual synthesizer. I have normalizer.float, which is just normalizing the sine wave so that it plays 1 hertz. 2 times this, because I couldn't get the correct, it was always at half frequency. I couldn't figure out why, so I just did 2 times to fix that. And then we have all of these harmonics, which is 8 harmonics sawtooth wave. And then we have just init voice. I'm still working on that, so that's not gonna come right now, but I'm just gonna work on get synth test value. And hopefully, probably it's not even going to be a test anymore. It's probably just going to evolve into being the section which which returns the value for any voice given with this struct. So yeah, that's pretty much an overview of what the code is going to do. And yeah, so I'm gonna keep on working on it. It's something cool. I wanted to share, working on it in the original language it was made in. So yeah.